the decomposition of functions. Our objective here is to find a composition of two functions and then find its domain. We're going to also decompose the function of a composition of two functions. Definition of a composite function is written in the format f of g. That's what this little circle here is supposed to represent, f of g. So we got a function of f and a function of g, and it's defined f of g of x. What does that mean? That means that I'm going to take this function f, and everywhere I see the x, I'm going to plug the g function in. Okay, and it's going to yield out a composition function of f of g. Okay, we can flip the order. And f and g is just the name of the function. It could be h, it could be k, it could be whatever you want to work with. So in this particular example, we're given a function of f and a function of g. And if you notice, they're both polynomials, and these restrictions, these domains, let me say this correctly. These domains have no restrictions, right? Because it doesn't matter what I plug in x for f of function. I have no restrictions. I'm going to yield out a positive answer. I can have negatives. I can positive zeros. Same with this one here too. So for the originals domain, it's going to be all real numbers. That helps in the end, especially if we have a fraction involved or something else, even roots involved, because fractions and even roots do have restrictions. So it's good to know what their original is, so it makes it easier to conclude the composition part of it. So now, what I'm doing is I'm taking my f function, and everywhere I see x, I'm going to plug in the g of x function. So I have 2 right here, right? 2 times x. And what is x now going to be? It's going to be whatever my composition function, or excuse me, it's going to be whatever my function is for g. So x squared minus 3x plus 8. And let's bring down the rest of that f function. So next, let me change this up a little bit. Let's go with this color. Next, I'm going to take my 2 and distribute. So now I have, I'm going to come over here. I have 2x squared minus, I got 2 times that negative 3, which is a negative 6x. 2 times positive 8 is a positive 16. And let's bring down that negative 5. We're going to put the 16 and negative 5 together because that's my only like terms. And when I do that, now I get a positive 11. So that is my answer for the composition function. And what is its restriction? Well, the f function and g function didn't have no restrictions. And then when we plugged them together, we still have no restrictions. So my domain here is negative infinity to infinity. Remember, you do not put brackets on infinity because you cannot stop infinity. Now, what if I switched the order? What if I said g of f? So that means I'm going to take the g function, and everywhere I see x, plug in f of x. So my g function was, 2, and then I had x squared. Let me go back. Minus 3x plus 8. And then let's look at our f function is 2x plus, or minus 5. So everywhere I see the x, I'm just going to plug in my f function. And now that I've done that, we have some work to do. If you notice, we have this here, this parentheses in a square. So that means we have 2 of those parentheses. So let's rewrite it. So I'm going to have 2, and then I'm going to put a bracket here. And I'm going to hang on just a minute on that next part. And let's change this to this color. So I'm going to bring this down of 2x minus 5 times 2x minus 5. I'm going to take this negative 3 times that positive 2x. So I get this. Take this negative 3 times that negative 5 gives me this. All right, so now let's bring down the positive 8. So now I want to clean up the inside that bracket. So in order to do that, let's, I believe this was left off, the square. There may be some notation, and it could have been me. Oh, I put a 2 in the place of the here. They didn't have a 2 right here. And let's just double check. Make sure they do have a square. So there was a typo right here. That's okay. I'm going to go ahead and put that 2 back. Let's just say that g of x in this one, let's just do it this way, since this is what I got written down. Oops. My apologies, guys. Give me a second. Let's just go ahead and say it that way, since it's the way I started. There is a notation error on this topped up part, so we're just going to work it out the way I got it. All right, so now I'm going to clean up inside that bracket. So first things first, let's go back. Let's rewrite this where it's a little bit neater. I got 2 inside this bracket. I want to use the full method. I'm going to say 2x times 2x is 4x squared. 2x times that -5, don't forget our negative sign, gives me a -10x. And then -5 times positive 2x gives me a -10x. And then -5 times -5 gives me a positive 25. And let's bring down the rest. All right, let's clean up our middle. If you notice, and you can clean up anywhere that you see like terms are at. So these two can be put together, and these two can be put together. So let's go ahead and do that. So now I got 2 in bracket, 4x squared. I got -10x minus 10x. It's like saying you're in the whole $10 and you spend 10 more, so you're in the whole 20x. And then let's bring down the 6x. And then it says I have $15 and I deposited 8 more. So now I have 23. So next I'm going to distribute this 2 to everything inside there because there's no other like terms inside there. So I got 2 times 4x squared, which is 8x squared. 2 times -20x, which is -40x. 2 times positive 25 is positive 50 minus 6x plus 23. And now we want to put together any like terms. And I notice I have this 40x, a -40x minus 6x can go together. And then this 50 plus 23 can go together. So let's do that. I'm going to come right up here and write it. It's equal to 8x squared. Right? 8x squared. So 40x minus 6x. So it's a -40, so it's a -46x. 50 plus that 23 is 73. And that would be my answer. That's my composition function. And it's still all real numbers. There's no restrictions on those. All right. So what if I have a function of x that's equal to square root of x and a function of g of x that's equal to x minus 3. So I'm just going to highlight these right quick. Let's talk about its restrictions right quick. F of x has square root of x. It's an even root, so yes, there's going to be restrictions. So what I'm going to do is take the radicand, set it greater than or equal to 0. Well, there's nothing to add or subtract to both sides, so we know this is restricted on anything smaller than 0 because it said x can be all larger numbers. So I know my domain, and if you need to write it on a number line, let's put our 0. I know that 0 is included, and it's going to go off to positive infinity. So when I write the interval notation for this one, it's going to be bracket 0, positive infinity. That's the restriction on that function. This function here, though, is x minus 3. It's just a polynomial. It doesn't matter what I plug in for x. I'm going to yield a real number. So its restriction, there is none. It's all real numbers. So let's find the f of g and g of f. So if I take the f of g of x, then everywhere I see x in that f function, I'm going to plug in the g of x function. So my f is the square root of x, and in the place of x, I'm going to put in x minus 3. And that's all I can do. There's nothing else to condense it down, put it together, or anything. So that is my answer there. So what I'm going to do for this one is state its domain. So what is this domain? I'm going to take this x, since it's an even root, I know there's a restriction, so I'm going to take that radicand inside that root, and I'm going to set it greater than or equal to 0. Let's solve. And this tells me that x is greater than or equal to 3, meaning the domain is 3. Whoops, I keep hitting that button. Sorry, guys. Is equal to 3 up to positive infinity. So that's where this composition is restricted at. So what we want to do before we make this our final answer is we go back to the original. Was there anything there? No, this worked out great. This is good. So this is the one we want, because the original was 0 to infinity, right? So this didn't go outside that window. Now let's plug in g of f. So I'm going to take my g function, and everywhere as I see x, I'm going to plug in my f function. So I got x minus 3. So f of x is square root of x. And then I'm going to have minus 3. Well, that's all we can do. There's no like terms to put together. So let's talk about its restrictions. Again, this root is the only part that's going to set a restriction. So when I look at that root, at square root of x, we already solved the domain for it, and it was 0 to infinity. And again, the domain is just finding the points that you can use that's going to keep it as a real number. So it'll tell you the restrictions, and then you have to state what would yield the real numbers. Okay, so that's what this next screen is talking about. All right. So let's do this. In calculus, we often need to recognize how a function can be expressed as a composition of two functions. This can be thought of as decomposing the function. So if h of x, so this function is called h, is equal to 2x minus 3 raised to the 5th power, and we find f of x and we find g of x, such that we get this here. H of x is equal to f of g of x. So what we're going to do is we're going to say, okay, the function of f of x rises that 2x minus 3 to the 5th power. That makes sense. Two functions that can be used for this compositions are, we can say, okay, f of x is equal to x to the 5th. And we can say our g function is equal to the middle part, which is the inside part of 2x minus 3. And then when we do that, we put it together. And then what do we have in the end? Now we have what we started off with. So what we did is we broke it down into parts that brought us back to the beginning. So thank you.